Good morning. My name is Marisol Campuzano, and this is Math 3120. My presentation today is based on Chapter 14, Section 14.2, Areas on a Geoboard. The lesson today is directed towards a fourth grade classroom, and the objective of the lesson is that by the end of the lesson, students will be able to find the areas of rectangular shaped polygons using geoboards, the addition method, as well as the rectangle method. So recently the students reviewed what a polygon is, and it is a simple closed curve with only segments as sides. Right below the definition here, we have an example of a pentagon, which is a polygon that has 1, 2, 3, 4, 5 sides. Because we're going to be finding the area, we need to know how area is measured. There's two ways. One way is by multiplying the length times the width of the figure. Another way is by using the square units. So here we have one square unit, and it's one small little box using the dots on a dotted paper. Today we're going to be using dotted paper before we jump into actually using the geoboards, because I want the students to be able to count the square units, see the square units, visualize them. So we're going to start with the addition method here on figure A. So here I have figure A on my dotted paper. If you can tell, it looks like it would have been a normal rectangle, but it looks like somebody kind of bit a piece into the corner right here. You can think of this as a cookie that someone bit into, a birthday cake that somebody cut the piece out of, or if we're going to be adding the square units, then we can think of this as a rectangle shaped pizza, and all of the square units are a slice. So that means that here we would have 1, 2, 3, 4 slices of pizza missing. Because it's not a full rectangle and this side's longer than this side, we can't really find the entire area without decomposing the figure. So by decomposing, I mean we're going to break this apart into smaller pieces. So what I'm going to do is I'm going to draw a dotted line right here in red, right in the middle, and I'm going to create this smaller rectangle and this larger rectangle. Over here I have labeled them rectangle 1 and rectangle 2. So for the addition method, what we need to do is we need to find the area of the smaller pieces, then we're going to add those together, and that's going to be the area of the entire thing. So over here, I'm going to find the area of this smaller rectangle first. So we're going to use the length times the width method. So the length of rectangle 1 is 1, 2, 3, and then the width is 1, 2. 3 times 2 equals 6. So the area of this rectangle is 6. We're going to do the same thing to rectangle 2, which is 1, 2, 3, 4, 5 as the length, and 1, 2 as the width. So 5 times 2 equals 10. Now over here I have this all written out. So area equals rectangle 1 plus rectangle 2, the length times the width, and we ended up with 6 plus 10. 6 plus 10 equals 16. Therefore, figure A's area equals 16 square units. And if you count out each of these square units, you will know that they are 16 square units. So before jumping into the rectangle method with figure B, I want to talk about why it is important to find the area of figures. So it is important because let's say you and your family are out shopping for a new couch for your living room, and you need to find the area to know if your couch is going to fit through your front door and if it's going to fit on your carpet in your living room. So that's why it's important for you to know before you try and push your couch in through your door and before trying to fit it onto your carpet. So that's why it's important to find the area of different figures. And I'm using a couch as an example because, like, if you can see my mouse right here, this kind of looks like a couch. I mean, this is one big piece, and then we have like either a little ottoman or just like an L shaped on the couch. So that would be a rectangular shaped figure. So an L shaped couch. And that's just something that you can find in your house. Another thing is that you can, let's say you find a new piece of furniture, a new desk that you want to put in your room, but you don't know if it's going to fit. So you need to find the area of your room. You need to find the measurements of all of the furniture that's inside your room to see how much space is left in your room. Then you need to find the measurement of your desk to see if your desk is going to fit in that empty, or that extra space that you have in your room. So now we can jump into figure B, which is the rectangle method. And, oh, see, this kind of looks like a couch right here where my mouse is at. So in order to do this, we need to create a large rectangle around the figure. So again, this figure is not quite a rectangle. So what we're going to do is we're going to create a rectangle. So I've created a rectangle here using green dotted line outside of the figure. And if you can see, this area and this area, they're inside the large rectangle, but they're not a part of the original figure. So what we're going to do is we're going to label those region 1 and region 2. So what we're going to do here is we're going to find the area of the large rectangle. Then we're going to subtract what we don't need. What we don't need here is those two regions because they're not part of the original figure. And we're trying to find the area of the original figure. So we can do this the same way that we did the addition method by multiplying the length times the width, or we can add the square units. So what I'm going to be doing is I'm going to be adding the square units to this one, since we kind of already saw how to do the length times the width. So again, this is a square unit, one little box. So what we're going to do is we're going to look at region 1 and region 2, and we're going to count the boxes. We're going to add the square units from both regions together. Then what we're going to do is we're going to subtract that from the larger rectangle. But before doing that, we need to find the area of the large rectangle. So for that, I am going to do length times width. So we're going to count here. 1, 2, 3, 4, 5, 6 is the length of the large rectangle. And then 1, 2, 3, 4 is the width of the large rectangle. 6 times 4 equals 24. And I actually have that written out right here. 6 times 4 equals 24. And like I said, we're going to be adding the square units. So again, we have region 1 and region 2. Now over here, I kind of wrote little dashes in each of the square units. So we're going to add those up. This is region 1, and we're going to add 1, 2, 3, 4, 5, 6. So if you can see, this is one little square. This is one little square unit. There's 6 square units in region 1. So I wrote it out right here. Region 1 equals 6 square units. We're going to do the same thing to region 2. We have 1, 2, 3, 4. In region 2, we have 4 square units. And if we wanted to just maybe check that, we can do length times width. So the width of region 2 is 1, 2 times its length would be 1, 2. 2 times 2 equals 4. We have 4 square units. Same thing with region 1. 1, 2 as a length, and 1, 2, 3, and 2 times 3 of the length and the width equals 6. So those answers match up. So you can always do that if you want to check your answer. If you did the length times the width, what you can do to check is that you can count the square units, and if you counted the square units like we just did, to check your answer, you can use length times width. Okay, so remember we found the large rectangle area, which was 24. So now what we're going to do is from that, we're going to subtract the areas of region 1 and the area of region 2, which we got by adding up the square units. So that was 6 plus 4, which equals 10. So we subtract 10 from 24, which equals 14 square units. In order to check this, what we can do is we can do the entire thing by using length times width, like we did before. And instead of adding 6 plus 4, we can subtract 6 from 24, which equals 18. Then we can subtract 4 from 18, which equals 14. So this answer equals the same as this answer. And in the other way, we subtracted, and this way, we added, then we subtracted. So again, if you want to check your answer, you can do the addition method. Then to check your answer, you can use the rectangle method. So for my students that seem that this is very easy, the next shape that you guys are going to try is this shape here that has halves. Yes, and if you're one of the students that still needs a little help, we're going to go over all of these steps again. But what I want you guys to do is I want you guys to take out some crayons because we're going to differentiate, which means that we're going to color in those smaller shapes in different colors. So we have this this one rectangle here in orange and this rectangle here in purple. That way you can kind of tell the difference between them. And tomorrow, we're not going to use geoboards just yet. I'm not going to pull them out. But what we are going to do is we're going to pull our computers out and we're going to log into this virtual geoboard, which I have open right here. And you guys are going to be creating your own images, your own figures. So look at this one. I'm going to create this one right here like that. If you guys want to try something like this, you guys can. So you're going to be creating your own image, your own figure. Then you're going to be finding the area of that figure. So you're going to be either using the addition method or the rectangle method that I just showed you guys. And then you're also going to be checking your answer afterwards. So for example, if you use the addition method to find the area of this figure, then you're going to use the rectangle method to check the answer. So that's going to be tomorrow's lesson, and I hope you guys are excited as I am because I want to see all of your guys' figures, and I can't wait to see you guys tomorrow. Okay? Bye. Have a nice day.